Hey guys, welcome back to AS SharpDev, your home for sharp coding in style. Today we're building a futuristic XML viewer in C WinForms. Not only will we parse XML, we'll visualize it like a modern dev tool, with syntax highlighting, structure, and interactivity. XML is powerful for structuring data, but let's be honest, reading raw XML is painful. It's like trying to debug a novel written in brackets. Instead, imagine giving your users a neat tree view to navigate through nodes, displays attributes and values instantly. That's what we're building today. Before we start with the actual code, let's quickly create a project and add a simple text box to the form. First, I'll quickly show you how you can easily read an XML file as a string if you sometimes need to. Of course, it's not the most elegant way, but it's enough sometimes. And there you have it. It works, but it doesn't look very good, right? Let's get a little more professional now. I'll put the entire code in my GitHub repo in case you have any problems. Of course, it's always best to code and understand it yourself. Feel free to let me know in the comments if you didn't understand or have ideas for improvements. Before we dive into coding, let's talk about why XML is still worth your attention. XML is everywhere: configs, APIs, game data, even documentation. It's human readable but ugly to look at raw. By turning XML into a structured, visual representation, we reduce cognitive load, spot errors faster, and make data exploration more intuitive. Think of it like the difference between raw logs versus a dashboard: one hurts your eyes, the other helps you see insights instantly. So let's turn boring tags into a glowing experience. We begin with a Form 1 and create our UI setup. TreeView will show the structured XML like a folder explorer. Rich text box will be our syntax highlighted code window. Split container splits the view left and right. Button load XML for interaction. Then inside setup UI, we style everything with dark mode vibes. So let's code first and I will explain later. We start by configuring the main form. I set the window title to Futuristic XML Viewer so viewers instantly know what tool we're building. The form size is 640 by 480, compact enough for a demo window but big enough to show structure and code at the same time. I center the window on screen so it appears nicely for recordings. The background color uses a dark RGB palette color. From ARGB 18, 18, 30, to create a subtle, modern dev dark base. I choose a monospace developer font, Consolas, at 11 points so code and UI text feel consistent and readable. Next I create a split container. This is the backbone of the layout because it gives us two panels, left for structural navigation and right for the code view. I dock the split container to fill so it takes the available form space. The orientation is vertical, which means left and right panels. The splitter distance is set to 60, that defines the initial width of the left panel in pixels. A small left panel gives a compact tree column. You can increase this value if you want a wider explorer. The split container background uses a slightly lighter dark tone for contrast. Now the tree view. The tree view is docked to fill inside the left panel so it expands to the panel size. Its background uses a darker bluish shade and the foreground is cyan to create a neon-like structural look. I remove borders for a cleaner, modern feel and use Consolas bold at 11 to emphasize node labels. The after select event is hooked with a short lambda that calls highlight node E. Node. That means whenever the user clicks an item in the tree, we visually mark the selected node. This connects interaction to visual feedback immediately. Viewers will see the selection glow as we click. On the right side, the rich text box is our code area. It docks to fill in the right panel, has a very dark background and white foreground for maximum contrast, and is set to read only so users can't accidentally edit during demos. Consolas 12 is used here for a comfortable code reading size. This control will display a pretty printed, syntax highlighted version of the XML so viewers can see both structure and content side by side. Next I define the load button. The button text is load XML, docked to the top of the form which makes it always visible above the workspace. I give it a height of 40 pixels, white text color, and an oversized bold Consolas 18 font to make it a clear call to action on the interface, perfect for live demos where you want a single obvious click to trigger the file picker. I hook its click event to bnload_click so it will open the file dialog and start the loading sequence. Finally, I wire everything into the form. I add the tree view to split. Panel 1 and the rich text box to split. Panel 2, then I add the split container to the form and add the button to the form. The order of adding controls matters. The split container is added first and the button is added after. Because the button is docked to top, it anchors at the top of the form and the split container fills the remaining space, that produces a neat top bar with the content area underneath. If you ever want the button inside the split container or pinned differently, change the docking or the add order accordingly. A few quick pro tips to mention in the video as you code this. Explain splitter distance to viewers. It's the initial width of the left panel in pixels. Tune it live so the tree view looks balanced. Point out the use of monospace font. It's a small detail that dramatically improves code readability. Note the after select event. You're hooking UI interactivity to visual feedback. Later we'll expand highlight node to clear previous highlights so only one node looks selected at a time. Explain why the rich text box is read only. It's a viewer, not an editor, but you can add a toggle to allow editing later. Mention docking and Z order. Docking works in the controls collection order. Adding the split first then the button gives the desired top bar layout. That would be the layout part. Now let's move on to the click event of our button to read the XML file. Oh, before I forget. There is a line of code missing in this part that will have a big impact later on during testing. Can you find the error? Let me know in the comments. And now let's move on. First, let's create a button-click method to open an XML file. We will use a file dialog so the user can pick a file instead of hard-coding paths. Next, I'll filter the dialog to only show XML files, so the user doesn't get lost in other formats. Finally, if the user selects a file, we'll pass that file name into our custom load XML method to process and display the content. Now let's build the load XML method. We'll start with a try catch to make sure our app doesn't crash if the file is invalid. Inside, we'll create an XML document and load the chosen file. This makes working with XML really straightforward. Next, let's clear any old nodes from the tree, so every load starts fresh. Now we add a root node with the XML's main element. I'll style it in deep sky blue to stand out visually. We then call a recursive helper method to add all child nodes beneath the root, giving us the full hierarchy. Finally, we expand the whole tree so the structure is visible immediately, and call highlight XML to format the raw XML content inside the text box. If anything goes wrong during this process, the catch block shows a clear error message instead of crashing the program. Now let's look at the highlight XML method. This method takes care of making our XML not only readable but also visually styled inside the rich text box. We begin by clearing the rich text box. That way, we always start with a clean slate whenever new XML is displayed. Next, everything is wrapped inside a try-catch block. This ensures that if the XML has issues or cannot be parsed, our program doesn't crash. Inside the try block, we create a new XML document and load the outer XML string into it. This gives us a structured XML object to work with. After that, we set up a string builder together with a string writer. These work hand in hand with an XML text writer, which is responsible for reformatting the XML. We configure the XML text writer to use indented formatting, with 4 spaces per indentation level. This step is crucial for readability, because it transforms a messy XML string into a structured, easy-to-follow hierarchy. Once the document is saved into the writer, we take the formatted result and assign it directly to the rich text box. Now the XML is displayed with proper structure. But we do not stop there. If formatting fails for any reason, the catch block ensures that the raw XML string is still shown, so the user never loses visibility of their data. The final part of this method is where the styling comes in. We call the colorize helper 3 times. Each call highlights a different element of the XML. First, all XML tags are painted cyan, which makes the structure stand out clearly. Second, all quoted attribute values are highlighted in orange, making them instantly recognizable. And finally, all attribute names are given a violet color, so they are visually separated from the rest. The result is a rich text box that feels more like a code editor, with clean indentation and colorized syntax. This makes even the most complex XML file much easier to navigate and understand. Let's first look at the colorize method. This method is responsible for applying syntax highlighting inside the rich text box. It takes in a regular expression pattern and a color. We start by using regex matches to find all parts of the text that match the given pattern. This could be tags, attribute names, or values, depending on which pattern we pass in. Then we loop through each match. For every match, we select that portion of text in the rich text box, and then we set its selection color to the given color. That's what paints the text with the correct highlight. Finally, after all matches are colored, we reset the selection to the start of the rich text box. This ensures the user doesn't see any leftover text highlighted as if it was still selected. The result is a dynamic syntax highlighting effect that can be reused for different parts of the XML. Now let's move on to the highlight node method. This one is much simpler, but it's an important part of the user experience. It takes a tree node as input and highlights it when the user clicks on it in the tree view. We first check if the node is not null. If it exists, we set its background color to a darker shade of blue, using an RGB value. This subtle highlight tells the user exactly which node is active, making navigation clearer. Together, these two methods bring style and interactivity. Colorize makes the XML text colorful and structured, while highlight node makes the tree view more responsive and user-friendly. Now let's break down the addNodes method. This method is the heart of our TreeView population. It takes an XML node from the document and the corresponding tree node in the TreeView, and then it recursively builds out the entire structure. We start by looping through every child node of the current XML node. For each one, we create a new tree node with the name of that XML element. Then we decide on its color. If the node has children, we color it light green, showing it's expandable. If it has no children, we keep it silver to indicate it's a leaf node. Next, we check if this node has attributes. If yes, we loop through all attributes and create subnodes for each one. These attribute nodes are formatted with the name and value, and we color them violet to make them stand out. After attributes, we handle children. If the node itself has child nodes, we call addNodes again, which is recursion. That way, the entire XML tree gets built out, no matter how deep it goes. If the node doesn't have children but contains text, we add that text as a new node. We also color text nodes orange to separate them visually from element names and attributes. Finally, we add the newly built tree node to the parent node, and the structure grows step by step. This recursive approach makes sure the TreeView mirrors the exact structure of the XML document, with elements, attributes, and text content all displayed in a clear, color-coded hierarchy. Now it's time for a test. What do you think? Does it look good? Something's missing, right? Not even loaded data is displayed. Damn, could that be the small error in the first method? Well, did you find it? Don't worry, I'll show you. We added our TreeView and the rich text box to the split container at this point, but forgot to add the split container to the form. As I said, it's just one line of code, but it has a big effect. Let's try again. Now let's summarize what we've built. We created a futuristic XML viewer in C WinForms. The user interface splits the window into two parts, a tree view for navigation and a rich text box with syntax highlighting for the raw XML code. We implemented a button to load XML files, methods to parse and display the structure, and even syntax coloring for tags, attributes, and values. The tree view updates instantly with nodes and highlights the active selection, making it not only functional but also visually appealing. In short, this tool is a powerful combination of structured XML exploration and beautiful code visualization. It's lightweight, it looks cool, and it helps users truly understand the content of XML files. Now, let's talk about improvements. We could add search functionality, so users can quickly find elements by name or value. We could include editing capabilities, turning this into a mini XML editor. We might even add themes, letting the user switch between dark mode, light mode, or even custom colors. And for advanced scenarios, exporting the tree view back into a formatted XML file would make this tool even more practical. And here's the part where we make our viewers hungry for more. If you enjoyed this project and want to go deeper into XML, I've got another video for you. In that one, I'll take you step by step into the structure of XML, explaining elements, attributes, namespaces, and how parsing works behind the scenes. That way, you'll not only know how to build a viewer, but also how XML itself works on a deeper level. Check out that video next, and don't forget to subscribe to stay updated with future tutorials where we take everyday coding tasks and give them a futuristic, stylish spin.